The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
Hey Ben, did you ever play Mario Kart 64 and in battle mode, you had to battle your friends and pop the 3 balloons that were off the back?
That's vaguely familiar.
So I had an idea where we could build remote control robots that have 3 balloons on them and you have to add weapons to them and you could battle your friends and try to pop their balloons.
All right, yeah, that sounds like it could be pretty good.
Okay.
Well, maybe we could do it as a 3-part episode.
Okay.
So how about this? How about in part 1, which will be today's episode, we will get some robot kits online, something that already exists to save us some time.
Oh yeah, that's a good idea.
Because we're also gonna have to figure out how to remote control each of them.
Yeah, so we need to build some like already established robots.
Yeah, but we can add our own electronics to control them, and we could each build one, Felix, Karen, and Ben. And then we could control them in different ways, so we could use Bluetooth, 2.4 gigahertz wireless, RC airplane remote. You know, we could make them all work differently. That way we don't have to worry about the signals colliding in midair. Because if you just bought like a pair of cheap RC cars, very likely they're gonna have the exact same frequency and won't be able to work at the same time.
Yeah, we wanted to be able to do 3.
Then in part 2, we can take our base robots and start adding weapons. Whatever cool features that will be used to pop and protect the balloons.
Your balloons are going down.
Yeah, we'll see about that.
Up.
And then finally in part 3, we'll finish up the robots and have a battle royale to the death.
Sweet. Yeah, let's do this.
Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
The kit I ended up with was the T500. It's bigger than Felix's robot, but smaller than Karen's, but it's gonna pack the biggest punch. So it's made out of steel, and it has pretty generic treads. They're shaped more like a tank rather than like a Wall-E or short circuit robot like my competitions. So I intend to use it to crush the competition, because a tank could totally beat Wall-E in a fight, or Johnny 5. I have to put all these wheels together in order to start building my robot. So mine is made out of laser cut steel, but where the laser starts and ends on each vector, there's a little bit of a burr, so I'm having to use this miniature file to remove some of the metal burrs. But other than that, it seems pretty straightforward. The other robots in this competition will be begging for mercy by the time it is over.
Out of the 3 kits that we got, I chose the Wall-E because it's small, it's compact, it's kind of a cool looking frame, and I think I'm gonna call it the Kitten because it's a kit, and it's tiny. And what distinguishes it from the others is that it's so small.
I was given these giant stacks of discs, so I'm assuming I just need to put them together in pairs. And I'm kind of going off of like how many of each screw and part I have and kind of doing the math and going like, well, if I need 3 for each of these, I have enough of those. So hopefully I'm using the right parts because there's no instructions. So all I have to go off of is the picture. But I was pretty good at jigsaw puzzles as a kid and just using the picture, so I think I got this. So when I was building my robot kit, I mostly was focusing on just getting it built and functional in the way that it was meant to be. And I started thinking about how I was gonna add on the weapons. And so I had to think about where the electronics and the battery pack were gonna live so that they didn't interfere with my weapon system. So I was trying to think of a way that I could attach them to the underbelly without them being actually on the bottom side of the plate so that I could easily access anything that I wanted to attach from the top so that the electronics weren't in the way of the screws or anything. So I'm thinking about maybe adding some sort of platform that goes between the axles so that I can still kind of access anything that I need to tweak with my weapon system without having to remove my electronics or the battery pack.
I'm trying to get this tread on. I think I have the wheels attached the way they're meant to. Luckily, when I was a kid, I had an erector set. So obviously, you know, that makes me a shoo-in. I'm gonna win. As I was putting together my kit, I was thinking, wow, this is kind of hard to do without instructions. But I was able to look at photos online and kind of figure it out. I did take a few tries to get the treads to work properly. You know, I had to have the right tension, but then there were like shafts on on the wheels, so it was hard to keep them straight, basically. Well, these drive gears are really weird. I don't know. You can put it together like this. You put this screw through here, and then it goes into, and it's like, how are you supposed to attach this to this? Because it's, I mean, there's a threaded hole there for this, but then like what, you're supposed to like clunk these heads up to it? But I mean, that's what makes this lines up to this properly if you do that, but really, that's the way to do it? Get your money for nothing and your checks for free?
You know, Ben, if it's too difficult for you, you can just give up now.
Karen, I didn't mean to say your robot should be hauling garbage. What I meant to say is it should be hauled away as garbage. If I was to build a kit like this, I would probably, first of all, include instructions. I feel that's kind of an important thing, you know. It's kind of like throwing your kid into a pool to teach them how to swim. Some people like that, but for others, it's kind of frowned upon. So yeah, I would definitely include instructions if I were to make a kit like this. Also, instead of like having a laser cut piece of metal and then bending it over, maybe have 1, 2, 3 pieces that are separate and then you attach them. I actually think that's how Karen's kit went together. Also, the wheels need to be sturdier and how they attach to the main frame should be sturdier. Because you've got all that tension on the tread kind of pulling the wheels together. So you have to make sure that they're mounted properly. Otherwise, if they're just mounted on one little point, they tend to bend. It's not how you build a car. It's not how you should build a robot kit. It won't matter though, because my robot is still going to be spinning circles around the smoldering wreckage of my opponents.
So I'm pretty sure Ben's trying to sabotage me because they got treads that were completed and I got one that was way too long and another one that was way too short. So I have to bodge my treads to get 2 that are the same length. So I'm really hoping that I have extra on this because otherwise I'm not gonna have enough pins to actually reassemble it and I'll have to find some sort of tiny rod that's the same diameter to build a complete tread. So I'm a little behind, but for good reason. But I'm making it work because I already got this one on and it looks like it's the right size, so. Yeah, so I don't know if it was a coincidence, but there were some issues with my robot kit. And I looked and there's like a little pin through the plastic treads and I was a little afraid of breaking them because they're plastic, so I had to be really careful. But I've removed pins from things before and I've had to deal with bearings and, you know, removing them. So I had a good idea of the method to do it. And so found some tools, grabbed some scrap wood and was able to kind of punch one of the pins out and adjust it to the appropriate size. So it's working fine now. I don't know if it was intentional sabotage or just because we bought kits from China, but got it working and my robot's good now.
Well, I got the treads on. I had a similar problem as Mr. Heckendorn with the gears not matching up, but I got that resolved. Fortunately, all my treads were already assembled to the proper length, so I didn't have that issue as well. I got this piece on, these 2 pieces on. I'm sort of tentatively mounting the circuitry on here. Now, as I was assembling the kit, I was thinking, wow, I like the design of this, and it's very interesting that it doesn't come with instructions, but fortunately on the website there are some photos of assembled pieces, so I was able to put it together. That was kind of fun. And aside from that, I was thinking about the transmitter and receiver, how I was going to put that together and get it to work.
I got my robot together, so I'm going to start mounting the battery. Felix bought several types of lithium-ion battery clips from Element 14. I think I'm going to go with these PCB mount ones, although I have to manually drill some larger holes into this board for them to fit, but that should work. Then once I have the batteries installed, then I can attach the motor driver, which it looks like my competitors are also doing. So I've got to pick up the pace. So I've been working on some laser cut and computer built parts for mine. I'm putting everything underneath the robot, or at least as much as I can, which will give me more room on top for my weapons. So we have a battery pack here with Velcro straps to hold the batteries in place so they can't get knocked out during a fierce battle. Then I 3D printed this mount for the motor driver. So yeah, let's see if this fits. So you notice that there were some 3D printed parts on my robot. The reason I did that was because I wanted all the electronics to be on the underside of the robot. That way they're kind of protected. Also, it gives me pretty much all the room on top of the robot to make my arsenal of mass destruction. So yeah, by using the 3D printed parts, I was able to mount the batteries, the motor controller, and the Arduino exactly where I wanted them to be to the metal frame. And then I took a picture of the frame and took a few measurements and drew it into the computer so I could get a perfect replica of where all the holes were and then design from that so everything would just line right up and I could screw it together.
So Felix found a phone app that I could use to control my robot, and being a traditional console gamer, I wasn't very happy about having to use like a digital interface, and I'm really glad it ended up sucking terribly because I really didn't want to use it. And with the way the app was, there was no way to add any auxiliary functions, so there was no way I'd be able to control any weapons I add if I made them electronic. They would have to be stationary. So thankfully, we decided against that method.
I knew that she wasn't gonna like it.
So this app is terrible and I don't want to use it, and it doesn't have any auxiliary options anyway, so I can't actually implement weapons with this, which kind of defeats the purpose of this competition. So,
Right.
not gonna work.
Okay.
So what are you doing for yours, and is it possible that we can kind of replicate that to work for mine?
Yeah, originally we didn't intend for this to come with the module,
Right.
or with the kit.
Yeah.
So we actually got 3 of these driver motors,
Okay.
motor driver boards. And this is a solution I came up with. So we got the motor driver board here going to the motors, and then this little board here with a microcontroller on it and a...
Is that Bluetooth or is that Wi-Fi?
No, this is, no, not Wi-Fi. It's a Nordic chip on here. It's a RF module, right? So they connected these. And so what I'm thinking for you, we could do something very similar, except instead of using the Nordic chip, we could try a Bluetooth module. We could pair it to Bluetooth adapters and connect them with microcontrollers and then to your board there. It's time for Felix's Corner. As it turns out, the control mechanism that we had set up for Miss Corbeil wasn't the most appropriate for what we're trying to accomplish here. So we've moved on from the ESP12E to these XBs here. And what we're going to do is make a custom remote control. And the first thing we're going to do if we want to set up the XBs is flash them. So I got 2 XBs and we're going to connect them to the computer, and I have the XCTU, which is the utility for flashing and modifying the XBs, and I've got 2 instances of it running so we can see each of them separately. So I'll add the radio. I think this is USB, I don't know, this is either USB 0 or USB 1, doesn't matter. Okay, it's going to try and connect, and now I'll connect the other one, the other XB. Now we'll go, it's going to read all the settings that are on it. All right, so I really actually got these set up yesterday. Everything was set up correctly, except on these settings here, there's a baud rate. I had them set to 115,200. They were communicating so fast that the microcontrollers that we had connected to them couldn't keep up with it. And I didn't realize that it was going to be a problem until half the day went by. So in order to set up these XBs properly so that they can communicate, they both have to be on the same channel, and then they both have the same PAN ID. And then there is what's called the destination high and destination low address. Right, destination address high, destination address low, and the source address. Now, the source address, say, is the address of one XB, and they each have their own address. Actually, this is 1, and this is 0. And then the destination, there's destination high and destination low. We only need to set the destination low. So the destination low on this XB will be 1, and the destination low on this XB will be 0. Make sure that the same channel, same PAN ID, the low on one is the my address of the other, and they both have different my addresses. And then the baud rate, again, make sure that is not some outrageous speed like I had it yesterday. And then make sure that all the parity and the stop bits are the same. And then we can go over here and we can connect to them with our terminal, and we can see them talk with each other through the XCTU interface. Hello. Yeah, there. See hello. I typed hello over here, and it instantly appeared over here. So I'm talking with myself now. Now that the XBs are set up and communicating with each other, I'll show you the code that I've got for them set up here. All right, so I have one XB connected to the Arduino on this controller board, and I have an XB connected to this Arduino, and this Arduino is actually acting as the receiver and is connected to the driver board for the motors. And both of the XBs are communicating through the software serial. There's 6 analog connected to the Arduino here. So there's the XY of A, XY of B, and then these 2 sliders. The analog is from 0 to 1023, but the integers that it's sending over the XB through the serial is going to be from 0 to 255. So we have to map those. So here's our main loop. So we update the controls. That means we ask, well, what's the value of everything? And then for testing purposes, we're displaying what the values are. All the way left is 0, all the way right and 254. This is the output from the receiver, and I verified that. What I need to do next is take the values that the receiver is getting from the transmitter and translate them into instructions for the controller. That's what I'm figuring out now.
So because the phone app didn't work for my robot, Felix designed me a little control board, but one of the parts was kind of blocking some header pins that we decided I might want to use for servos in the future for my weapons. So he was showing me how to read the chip pinout so that I could solder some of those available pins, like the GPIO, to a header pin that I can plug servos into later. Well, since we're not using that other module, I am going to reconfigure my battery setup so that there's a little switch on here and so that I can hook up to this. Because I discovered that this is no longer necessary to have on my battery setup because there's one right here. So I'm also going to try to condense this so that it fits as small as possible on the bottom of my robot so I have more room for weapons.
I've wired up my controller and the remote and the batteries and pretty much everything to the robot. I have the 5-volt line disconnected because I have it plugged into my USB port. I'm going to send it some test code, which should get it to go forward and back at different speeds. Flashing now. This one seems a little stickier. It might be something with the treads. I'll have to look into that, but it is moving. So what I'm going to do next is test the remote control. I have my controller ready to go. I'm going to disable the test and allow it to take the pulses from the servo controller, which is what the remote controller actually is. They'll turn those pulses into a different kind of pulse to drive the motors. I'm still working on the mapping and speed, but I have the basic movements down. Forward, back, that left tread is still a little sticky, and turning. See, it turns faster to the left than to the right, because when you go left, this is the drive wheel, and this one is the drive wheel when you go right, and this one's kind of sticky for some reason. Let's see if I can drive over something. Let's pretend this is, Felix's robot. Yeah, smash it into oblivion. Oh no, the edge of the table, don't fall off, robot, no! I don't know if that hiccuping is low battery or if it's a ranging issue, but the communication works, that's the important thing. I'll figure out the rest later. My solution for how to remotely control my robot was to get a commercially available RC plane remote with the 2 analog sticks, which is actually 4 because you got up, down, left, right, up, down, left, right, because I knew I would have multiple controls that way. I could use one for movement and one for weapons. And then there's a little receiver unit that comes with that receives the signals coming from the controller and directly drives servos. So then I took that servo driver and I plugged it into basically an Arduino, and the Arduino took those servo pulses and just turned them into numbers basically. And then I took those numbers and translated them into PWM signals to drive the motor driver. Because you can't directly take a servo control signal and make it drive a DC motor. So I use the microcontroller to translate it. So I still get the analog movement, and I also get the cool remote that has a really good range. So I could beat my opponents from a block away or up close and personal. It's like I might be so embarrassed by their crying and wailing that I don't want to be seen near them. So I'll go over there and do the destruction deeds.
So I've got Miss Corbeil's transmitter and receiver functional enough and wired up to the point where I can do a rudimentary test. I'm doing the test on my machine here because I don't know quite how Miss Corbeil wants to lay her things out. She'll have to build her system however she wants it, but we're just going to do a test on mine. Turn on the receiver, turn on the transmitter and give power to the receiver. Yeah. So let's see what happens. Oh, there it goes. It's alive. Cool. Yeah. I think it browned out. These batteries are just barely enough to drive this system. The 7805, it has a dropout, and I think that dropout's causing the microcontroller to brown out. The solution I'm going to come up with is I'm going to make a larger battery pack, and I might put on a switching regulator, but I'll start with a larger battery pack. So I'm going to give you a little overview on this tiny little mechanoid here, the electronics that I use in it. So for the transmitter, I have 7.4 volts coming in to a 5-volt 7805 regulator, and there's also a 3.3 volt regulator to provide voltage for an XB, and the Atmel 18 Mega 328 PAU, which is the same microcontroller that is on the Arduino. And then there's some analog sticks and analog sliders on here. So the XBs, obviously they communicate with each other. There's another XB, another Atmel, and this translates the signals that go into this UK1122 motor driver here. Also, in this configuration, there's 7.4 volts, but I'm gonna change that. And then there's these two honking motors down here. Now I'm going to pass this on to Miss Corbeil, and she's going to utilize it for her system. And then I'll build another transmitter receiver pair for my machine. And then after that, I'm going to start putting some defenses and weaponry on it. Now that I built that solution for Miss Corbeil, an alternative for me that I was thinking was to pair a PS4 controller with a Intel Edison via Bluetooth. So I have to figure out how to take the signal that the PS4 is transmitting and turn that into GPIO signals. If I can do that, then that's what I'll use.
Do I have any weapon ideas? Oh, I've got a few. Maybe kind of like a reciprocating spiker, like because we're going to be popping balloons on the enemy robots. Also, I want it to be on kind of a vertical arm, so the robot can turn left and right. So I don't really care about the left and right movement of a weapon, but I might need to change the height. Felix's robot is small, Karen's robot is bigger, so I gotta, aim my weapon down to fight Felix and aim it up to fight Karen. It also might be cool if my robot could play the Jurassic Park theme to use as psychological warfare against Karen.
Okay, so for my weapons, I want to scrap a bunch of parts and reuse them because one of the things I love doing is finding an object and using it in an unconventional way so that people look at it and go like, what the heck is that? And then I tell them what it is and they're like, seriously, that's awesome. I was thinking of getting a broken umbrella and using the skeleton from it, and then at the ends of those, maybe getting some like the pipe insulation foam that goes around it, because I think I have some scrap lying around, and the pins would go through that really easily, and then I could glue them on the inside, and I don't have to worry about the pins falling off or like getting bent and going all wonky. If I put the foam insulation on the umbrella with pins sticking out, then maybe I can even get the umbrella to like open and close like wings or something. I don't know if that'll work because that might pop my own balloons. I still have to think about it. I like the idea of using the foam insulation and maybe the skeleton of the umbrella. That's where I'm thinking right now. It might evolve, but that's what I got so far.
So you want to know about my weapon ideas for episode 2, huh? Well, I'm keeping my weapon ideas under wraps because this is a competition, right? I may be sportsmanlike and I might help out, but I'm not gonna reveal my trade secrets. Okay. But I am gonna go for some Motzi points and try to make my little kitten look really cool.
Well, that's all the time we have for today, but it looks like we got our 3 robots built and moving around via remote control.
And look, my robot's so cute. It will fool you while it's destroying your robot.
Yeah, we'll see about that. So in the next episode of this series, part 2, we're going to add weapons to the robots so they can pop each other's balloons. And then in part 3, we'll add armor to the robots, finish them up, and then have the battle royale.
So tell us about your ideas for a battling robot on the Element 14 community on element14.com/TBHS.
You can also go there to read about our other upcoming episodes, builds, and special events. We'll see you next time. You're going down. You're yelling timber. Your robot will be turned into pop cans.
Oh, it's kind of like making out. That's not. Yeah. I don't know. I'm like, and I'm done talking.
I got some top secret weapon ideas for. When I first heard about the challenge, it's kind of well built, so to say. I got a cool name. I'm gonna call it the kitten. I said, hey, Mr. Bill, I know you probably. I knew you wouldn't like this anyway, but our new hit single, doof doof doodle doo doo, doof doof doodle doodle doo doo.
The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.